So guys, this is what you are looking for, yeah. So in this video, we are going to look at the midterm review questions. That's the computer-based midterm review questions on multivariable calculus, math 252. So where there's a question, I think we met the same thing in the exams, even though the values are not the same. I'm betting you are. When I go through this with you and give you the understanding, you are good to go with the midterm. And I'll give you all the tips. Let's go. So the first question you're going to take here is that he gave us the function of this, and they are asking to find it in what? In W, in X, and in Y, and Z. So these are four variables. Now the trick here is that sometimes the arrangement is different. So sometimes you should look here. This one, they say the partial derivative of the function of W. So W. So you're going to partially differentiate it with W and then put in the values that this represent W. See, W, X, Y, Z. Be careful. These values and the one to prevent you is this value. Because some people say that always here start with X. So X, Y, Z, W. This value corresponds with how they've arranged this. So what you do now is that you are going to partially differentiate it with respect to W and then put the values inside. Partially differentiate it with respect to Z and put the values inside. So there, let's go to the solution. So with the solution, this is how they did. This is the solution. So first, you partially differentiate it with respect to W. We get X, Y. Then you get what X. Well, what is X? 1 and Y is 3. And you put it inside and you get this. Then you choose your answer. Because when you go inside here, you can see that the answer is there. When you go, you see that the answer, first one is. And the key thing I'm telling you is that look at the instructions. Please, the computer base deals with what? It's command. They say 1 decimal place. So when you get 3, 3.0. When you get 4, 4.0. Please, when you get 1, 1.0. Note that. So this is the solution. And the second one is respect to X and you put the values inside. The third one is respect to Y and put the values inside. And at the end, very simple, 1.0. And in this question, they asked us to find the slope of a sphere. How I love this question. It came in our exams a lot. Miss them, I had like 4 questions from here. This one, you don't need to stress yourself. The formula will be negative y over then z. Let me check. So negative y over then z. Just put this in your head. So you take this is x, y, z. So negative y over what? Z. And that'll give you the answer. Simple. So always you should know that it's negative y. The slope of a sphere, negative y over z. And you get the answer. Let's go to this question. These are some theory questions that you should know. It's theorems. Some of them I've not done videos on them yet. So when I get there, I'll let you know. But always, or at least you should have an idea on it, right? Yes. This I think is one of the topics, subtopics. You do this one. So for this, I'm holding on for a moment. So after I've done that video, I think you can come back and answer back. You can also go through it and see, right? These are rules. I think relative critical points, finding the critical points, right? That one is a maybe later part of the course. You find the critical points, that kind of thing. I'll also take you through that. I get in it, yes. But all the case, you can also look through and see the answer that they had, which is these are the rules that you should follow for finding the critical points. We'll get the saddle point and everything. I'll do that. So, with this, also, it's a rule that you should know, right? So that one you should know. I think it's also part of the course. This one, I think we didn't meet this, but this one we met it. With this one we met it in the missing. Yeah. What I'm looking for is this. And the local approximation too, I'll do it with you guys. That one too, you've not done it yet. I think it will be my next video, the local approximation, right? It's a formula you need to follow and it's very simple. For here, they say the linear local approximation is of square root of x squared plus y squared at a point 3 and 4, giving us this, right? So we are finding a1, a2, 3. The solution is here. What do that? There's a formula for finding the local approximation. You find there's the f of x and y. Then you find the f of x by the change in x, f of y by the change in y. That's what they did. So you put the values inside the function given to you here, and you get 5. Then you put the values inside. So at the end, you're going to get this. You differentiate it partially and put the values inside. So it's very simple. Differentiate x partially and put the values inside. Then x minus x naught. X naught to be given to you in the question, which is the point at which the thing occurred. So the point is what? 3 and 4. Very simple as that. So I'm using this to teach the linear approximation. This is partial differential of y. Then y minus y naught. Y naught also is given. So they had this. This is a function. The function is given to us as x squared plus y squared all squared. So you put the value inside, you get 5 for the function. Then you partially differentiate this and put the values inside times x minus 3. You do that. And at the end, you are going to get all the values. There's it. Very simple as that. This is what I'm looking for. In our exams, a lot of this scheme, like we've done this. If you don't watch it, go and watch the limit and continuity. They ask us to consider a function of x squared plus y squared over x squared minus y squared along y-axis. So along y-axis, what happened? X is 0. So you put 0 inside. This is what they did. Along y-axis, x is 0. So you put 0 inside and you get -1. Very simple. I've done that in my video. And this is limit along curve. And here's along what? Y-axis. We have a lot of questions came from here. And at y-axis, x-axis, y is 0, and you put that you had -1. And along the curve, y is equal to x. Wherever you see y, you put x there, as they've done here. Then you are going to get it does not exist. Now, I told you that one thing I told you that when you find along curve, right, and you do all of this and you don't get the same value, what happened? The limit does not exist. So with this, we didn't get the same values for all of them, right? We had negative half 2x over 0. We had does not exist. So at the end, they are going to ask you. You see, they asked us to find all. We did this in my video. I did all this in my video. And at the end, they're going to ask you that what can we conclude from the result above? If you don't get answers of the same, like if you don't get the same answers from all, it means that the limit does not exist. So that's the answer. The limit does not exist. This is what. So with this, it's asking us to find the y over the x, or for the equation of this. So with this, let me tell you something. What you must do now is that first, when they give you this, you must send all this here and equate it to 0. So you are going to send all this. So it will be x cubed plus 3y cubed x squared z minus 3y plus z squared. Then what you do now is that there's a formula that says that for you to find this one, dy over dz will be equal to negative the function, that is the diagonal one, which is z, over the function, that is partial derivative of what? Y. Let's go to the solution for you to understand better. So with the solution, this is it. So look at this. The trick is that whenever they ask you to find this, right? Even though I'll do it in my video, whenever they ask you to find this, it's just diagonal. This should go with this, and this should go with it. Because with differentials, right? F of y goes with what? Dy. I getting it? And f of z goes with what? Dz. So as I said, you send all this one here, then you partially differentiate z, you partially differentiate y, then you negate it. Very simple as that. I getting it here. This is what I was telling about. You get a lot of this question limit, a lot of this question. So with this, just put the values inside. And please, with this question, you get it's plenty. So you should know how to use your calculator and punch it fast, right? With this, I don't need to take you through. They just put the values inside. Right? This also you put the values inside. So always try and put the values inside. This one they say, does the limit exist? No, it does not exist. This does not exist because 9 over 0 is infinite. It does not exist. It's infinity. You see, this is it. So the limit does not exist. The difference between you getting an infinity and does not exist. They are not asking you the answer that you had. They are asking you the limit, so it does not exist. I getting it? Yes. Let's go to this one. This one, they asking us this, right? The limit is what? Infinity. The limit is infinity. I getting it? But with this one, the limit does not exist. Since, look at this. Since, if for it to exist, let's see this. You see lim 9 over x. Limit of the function 9 over x. Positive 0 should be equal to negative 0. But in this case, the positive 0 will give you positive infinity. And the negative 0 will give you negative infinity. So the limit does not exist. But with this, the reason why the limit is what? Infinity is because, let's establish this. it is squared. So negative, when you even put negative 0, you're going to get positive infinity. You're going to get positive infinity, and it knows this. So if the limit, when you get maybe an answer over 0, and you do it with a negative 0, and you get the same infinity sign, that means that what is infinity. But if you don't get the same infinity sign, that means that it does not exist per what we did here. Oh, this one too is very simple. You put the values inside. This one, you're going to get a lot of these questions. So what you do is that you just put the value of x inside wherever you see x, and you get the answer very simple, and you choose. That's why with MIDSEM of multivariable calculus, you're going to get, it's very simple for you to pass. Where they're giving you x and y value, you put the x and y values inside. Do you know the whole aspect of the trick about this? The trick is that sometimes you don't get the time to finish because it's plenty and it's very simple for you to, you point your calculator. And one thing too, I don't know how to set the computer-based question, but usually when you make a mistake, you're going to get the answer inside this, and you choose. And it's sometimes I'll be like, how did they say the question? They even sit down and try and put, like, they'll look at how we are going to think, and they'll bring the answers. I'm very surprised for that, right? With this question, so it's all limits. They've given it to us, you put the values inside, you get the answer, and you choose. As I told you, you're going to get a lot of these questions, so be prepared. And I think it's very advisable if you have calculators, right? Yeah, it will be very simple. They are asking us to find the multivariable calculus, blah blah, such that t, x of t is equal to this, x of y is equal to this. So this is just substitution you're going to do. Just substitution. Wherever you see x, you put what? T cube. This is a substitution. Wherever you see y, you put what? T squared. And wherever you see z, you put what? T squared. And you just put inside and just substitute and get the answer. Simple as that, because they gave it to you. Look at what they gave you. It's very simple. They gave you the rules. Wherever you see, just put the values inside and you're good to go. And they asked us to find in terms of what? Xt and yt. This is very simple. I think we had this question. It's just substitution. This is always substitution, right? And here, after you are done with that, you just put the values. So wherever you see t, you put 0 inside, 0 inside. So from here, that's what we did. So you are done with that. You had the t, so you put the values inside. That's all. It's substitution. We had that question, so you can sit down and do that one. It's very simple. The maximum value of a function, blah blah blah. Okay, it's at 7. Wow. Okay, this one will do it, but yeah, Lagrange approach. We've not done it yet. It will be my video. This one, I think if you're able to finish to this one, Lagrange, this one, you are going to expect this in your midterm. But if you don't finish, oh, it's very simple. You are not going to get it in your exams. But with the questions that I have seen, or with the question that I did, mostly is the limit. You're going to get a lot of limit questions, and a lot of limit questions, a lot. The reason why I'm skipping some of them is that we've not done it yet. So you can also go back and see the answers. But I didn't get that one in the exams because without time we've not gotten to that place. But I don't know by your end whether you get to that place. Here to it's just some concept. Which of the following condition is for two variables? You know that this is it. F of x and is not this. This is it. Or let's see. Okay, this one they gave the answers. Which of the following parametric equation is associated with the line, blah blah blah. Let me see. Yeah, parametric equation. That one you do it. Is it the middle of the course or something? Yeah. Don't worry. Some of them I'm skipping them because you've when you get the chance to do it, you come back and you see it, you'll be able to solve it. The directional derivative too, we are going to do the directional derivative. Yeah, it's very simple. We are going to do the directional derivative, so you can look through the solution and you see how it was solved. How do you find the z? Find the differential of the z. This one, what do you do? Who can tell me? You just do it with what? The x. This one, the values are what? Differential. We have x and y, so we are going to differentiate it partially with respect to x and write dx plus partial differentiate with respect to y and dy. And that's very simple as that. This is what they did. Simple. The x and the y differentials. We've done it from the previous video. And this is for us to do is application question in milligram. Suppose the concentration of C milligram of a medication in a particular blood stream is this. So they gave you the equation to be this. This is the equation given to us. So they are asking us based on the information, find the value of this. What do you do? Substitution. You put the values inside. Simple. Just substitution. And suppose that the concentration is this, and the target is half of that. What will this one do? So with this, it's just substitution. First, you need to have this one, and you just substitute the value given to you. And then the next one is that we are finding the x, right? We are finding the x. What do you do? Because they ask us to find the dosage, because look at this. The x represent the dosage and the t represent the time. So we are finding they say suppose the concentration is 9.8 milligram per liter. It's targeted in half an hour. The dosage, just go back here and you are finding z, because they gave you the answer to 9.8. So you're going to equate this to 9.8 and you get your answer. So thank you very much for going through the review question with me. You can go back again, and a lot of limit questions. As I said, a lot of limits, and the differentials, partial derivative for the midterm. I'm betting you. So be ready for that. Thank you very much.